This is a hands-on class, so open the lab guide and craft prompts alongside me. Last class you learned system prompts and 82.1, how to set Claude 39, S-role, rules, and context. Today, we go deeper into the actual art of asking prompt engineering. Here is the fundamental truth that makes this skill so valuable. The exact same model asked the exact same underlying question can give you a vague, mediocre answer or a precise, brilliant one and 8200, and the only thing that changed is how you phrase the request. The model at INT9's capability is fixed. How much of that capability you unlock depends entirely on your prompt. Prompt engineering is the craft of writing prompts that reliably draw out the best the model can give. And the wonderful thing is that a handful of simple, learnable techniques account for most of the improvement. You do not need tricks or magic words. You need to be clear and specific, to show examples of what good looks like, to give the model room to reason on hard problems, and to structure your request well and 8112, then test and refine. Master these, and you will consistently get excellent results where others get frustrating ones. This is one of the highest leverage skills in working with any language model, and by the end of today, you will have the core toolkit. Let us learn to ask well. Here is our path for today. First, why prompts matter so much. Second, being clear and specific. Third, giving examples. Fourth, letting the model think. Fifth, structuring your prompt. And sixth, testing and iterating. Let us dive in. Let us begin by really absorbing why prompt engineering is worth learning, because the leverage here is enormous. Consider a single fixed model. Ask it a question one way, and you get a shallow, generic response. Now skip the same thing another way and 8212, more clearly with the right framing and 8212, and you get a thoughtful, accurate, well-structured answer. Nothing about the model changed. The entire difference in quality came from the prompt. This tells you something important. The model has far more capability than a careless prompt reveals, and your job is to phrase the request so that capability actually comes out. The old programming saying NAO 2020, garbage in, garbage out, NAO 2021 applies perfectly. A confused, ambiguous, underspecified prompt gives the model almost no chance to help you well, and A212, it has to guess what you want, and it often guesses wrong. A clear, well-constructed prompt, by contrast, gives it everything it needs to give you exactly what you are after. The quality of the output is bounded by the quality of the input. Prompt engineering is simply the discipline of making that input as good as it can be. And here is the encouraging part. This is a learnable skill, not an innate talent or a bag of secret tricks. There are a small number of concrete, reliable techniques, and A220, the ones we cover today, and A220, that account for the vast majority of the improvement. You do not need to discover magic phrases. You need to apply clear principles, be specific, show examples, allow reasoning, structure well, and iterate. Once these become habit, the difference in your results is dramatic and consistent. Given how central language models are becoming to software, this is genuinely one of the most valuable skills you can build. Let us go through the techniques one by one. Numsai, that's Haikawai. A signed fixed model gives a poor or an excellent answer depending purely on how you ask. Because output quality is bounded by input quality and I2I2 so prompt engineering, the learnable craft of asking well through a few concrete techniques, is what unlocks the model and 39's recapability, making it one of the highest leverage skills you can build. The first and most important technique, the one that fixes the majority of bad results, is simply to be clear and specific. Consider a vague prompt, any 80 office. Write about dogs, any 80 office, or dogs, any 80 office. The model has almost nothing to go on. How long? For whom? An 8112, a child, a vet, a general reader. What angle? An 82112, care, breeds, history, training, what tone and format. Facing all that ambiguity, the model has to guess every one of these, and whatever it produces, will likely miss what you actually had in mind because you never told it. A vague prompt is a request to guess, and guesses disappoint. Now make it specific. In 2020, write a 3-paragraph, friendly guide for first-time dog owners on house training a puppy in a warm and encouraging tone. In 2020, suddenly the model knows the length, the audience, the exact topic, the purpose, and the tone. There is nothing left to guess, and 82824, you have specified it. And the answer comes back far closer to what you wanted, because you actually told it what you wanted. The more of these dimensions you pin down an 80-othov, audience, length, tone, format, focus, and 80-othov, the more the output converges on your intent. The principle to internalize is that the model cannot read your mind, it can only respond to what you actually wrote. Everything you leave unspecified, it must fill in with a guess, and every guess is a chance to diverge from your intent. So spell out what matters. Who is this for? How long? What tone? What format? What should it focus on or avoid? This single habit, N8224, replacing vague asks with specific ones, N824, will improve your results more than any other technique. When an answer disappoints, the very first question to ask is, N8020, was my prompt actually specific about what I wanted? N8021, usually it was not, and adding that specificity fixes it. So the takeaway, be clear and specific, and 8205, state the audience, length, tone, format, and focus, and 8112. Because the model cannot read your mind and must guess at anything you leave out. Replacing vague asks with precise ones is the single most powerful prompt engineering habit, and the first fix when an answer disappoints. The second technique is wonderfully effective and often underused. Instead of only describing what you want, show the model an example of it. Describing a desired output in words is useful, but it has limits. N8084. Some things are hard to capture in a description, like a particular style, a specific format, or a subtle tone. Showing is far more powerful than telling. If you give the model 1 or 2 concrete examples of exactly the kind of answer you are looking for, it studies those examples, extracts the pattern, and 82112, the format, the style, the level of detail, and 82112, and produces new answers that match it. This is often called few-shot prompting because you give a few examples or shots. Picture you want product descriptions in a very particular style. You could try to describe that style in words and hope, or you could simply show 2 well-written examples in the exact style you want, and then ask for a third for a new product. The model will match the examples closely, and 824, the same tone, length, structure, and 824, twofold because it has a concrete pattern to follow rather than a vague description to interpret. One good example frequently communicates more, and more precisely, than a whole paragraph of instructions about what you want. This technique shines whenever the output has a specific form or feel that is easier to demonstrate than to articulate, a data format, a writing style, a way of classifying things, a structure of reasoning. Rather than struggling to describe it perfectly, you show a couple of instances and let the model generalize. It is one of the most reliable ways to get consistent, on-target output, and it pairs beautifully with being specific. And 8112, specificity tells the model what you want, and examples show it. When words alone are not getting you there, reach for an example. So the takeaway, show, done an A39, T just tell an 80-200 well. Give the model 1 or 2 concrete examples of the answer you want, and it extracts the pattern and matches it far more reliably than from a description alone. This few-shot approach is especially powerful for a specific format, style, or structure that is easy to demonstrate than to articulate. The third technique is a genuine game changer for hard problems, and it is almost magically simple. Give the model room to think before it answers. The trick is to instruct the model to work through the problem step by step, reasoning it out before committing to a final answer. Just adding a phrase like ane etau1 to atau1, think step by step in etau1 or ane etau1. Work through this carefully before answering etau1 atau1. Changes the behavior instead of blurting out an immediate answer. The model lays out its reasoning and 8212, the intermediate steps and 8212, and only then gives the conclusion. You are explicitly inviting it to reason rather than to guess. Why does this help so much? Because on complex problems, an 8212, multi-step logic, maths, careful analysis, and 8212, the reasoning is where correctness is won or lost. A model forced to answer instantly commits to its first instinct with no chance to work through the steps, and on hard problems that first instinct is often wrong. Given room to reason first, it can build the answer up piece by piece, catch its own missteps, and arrive at a markedly more accurate conclusion. It is the same reason a person gets a hard question right when they think it through and wrong when they answer off the cuff. This connects directly to the extended thinking you learned earlier and 86 tool. And here, you can invoke a lighter version of the same idea purely through prompting. The key judgment is to use it where it pays. Reach for an 8 to a 20. Think step by step a 8 to a 9 on genuinely hard, multi-step problems where the reasoning matters. For simple lookups, it just adds length without benefit. But for the hard ones, this one technique can be the difference between a right answer and a wrong one at the cost of a single instruction. It is the highest value trick in the toolkit for difficult reasoning. So the takeaway, for hard problems, instruct the model to think step by step before answering an 8-200 tool, explicitly inviting a reasoning rather than a snap guess an 8-200 tool, because working through the intermediate steps is where correctness is won on complex multi-step tasks. Use it where reasoning matters, and it can turn a wrong answer into a right one for the cost of one instruction. The fourth technique becomes important as your prompts grow more complex, structuring the prompt clearly so the model can parse exactly what you are asking. When a prompt contains several parts and A22L, some instructions, some data to process, some context, and A22L, it is crucial to separate them clearly so the model does not confuse your instructions with your content. A common and effective way is to use clear markers or delimiters. Put the data to be processed inside obvious boundaries and keep your instructions distinct from it. For instance, an A224, summarize the text between the markers, and A2201 with the text clearly fenced off. Now, the model knows exactly which part is the instruction and which part is the material to act on with no ambiguity. For a genuinely complex request, go further and give the prompt sections, almost like a little document with headings, a section for context, a section for the instructions, a section for the input, a section for the desired output format. This organization helps the model track a multi-part request without dropping something, and place your most important instruction where it stands out. An 82.5. A clearly stated key task is far less likely to be overlooked than one buried in the middle of a long, unstructured paragraph. Structure makes your intent legible. The underlying principle is that a well-organized prompt is easier for the model to follow correctly, exactly as a well-organized document is easier for a person to follow. When everything runs together in one undifferentiated block, an A212, instructions, data, and context all jumbled, an A212, the model is more likely to misread which part is which and get something wrong. When the parts are cleanly separated and labeled, it reliably does the right thing with each. As your prompts move beyond a single simple sentence, this structuring becomes essential to getting consistent, correct results. Key structure is key communication. So the takeaway, structure a complex prompt so the model can pass it, and A212, use clear markers to separate your instructions from the data to process, give a multi-part request labeled sections, and make the key instructions stand out, and A212, because a well-organized prompt, like a well-organized document, is followed far more reliably than one jumbled into a single block. Before we talk about iterating, let us consolidate the core techniques into a simple order of operations you can reach for on any prompt. First, be specific. This is your default always-on move, and it fixes the majority of poor results on its own. Before anything fancier, ask whether you have actually told the model what you want, and A2 the audience, length, tone, format, focus. Clarity first. It is astonishing how often simply being more specific is the entire fix. Second, if clarity alone is not getting the form or style you want, give examples. Show one or two instances of a good answer and let the model match the pattern. This is your go-to when the output has a particular shape or feel that is hard to pin down in words. Specificity plus examples handles the great majority of everyday prompting beautifully, and 8212, you tell it what you want and you show it. And third, for genuinely hard, reasoning-heavy problems, let it think and 8212 pal, add and 8212, step by step and 8212, so the model reasons before answering. This is the tool you escalate to when the task is complex, not something you need for simple asks. So the mental order is: start specific, add examples if the form needs it, add step-by-step reasoning if the problem is hard, layer them as the task demands, and underpinning all three, structure your prompt clearly so the model can follow it. Master this small order toolkit and you can handle almost any prompting situation deliberately rather than by trial and error. Clarity, examples, reasoning, and 8212 in that order. So the takeaway: apply the core techniques in order and 8012. Start by being specific, which fixes most problems. Add examples when the output in ND form or style needs showing, and escalate to ND. Think step by step and 80 for genuinely hard reasoning, ND all on a clearly structured prompt, giving you a deliberate toolkit for almost any situation. The final and most important habit ties the whole craft together. Prompt engineering is iterative. You do not write the perfect prompt in one shot, you refine your way to it. Your first attempt at a prompt is a starting point, not a finished product. And that is completely normal and 80-second to evolve, even for experts. You write a reasonable prompt, try it, and see how the model responds. Some of the time it will not be quite right, and 8021, too long, wrong tone, missed a requirement, faltered on an edge case. That is not failure. It is exactly the feedback you need to improve the prompt. The professional workflow is a loop: write, test, observe, refine, repeat. The discipline that makes iteration effective is to test on real and varied inputs, especially the hard ones, and to change one thing at a time. It is easy to craft a prompt that works on the obvious example and breaks on an unusual one, so deliberately try the tricky cases. And when you improve the prompt, change a single thing, an A201, add one piece of specificity, or one example, or a reasoning instruction, an A201, then test again. If you change 5 things at once and it improves, you do not know which change helped. Changing one at a time tells you exactly what works, so your prompt gets better in a controlled, understandable way. And notice how the fixes map directly onto the techniques you have learned. Answer too vague or off target. Add specificity. Wrong format or style? Add an example. Reasoning errors on a hard problem. Add AA220. Think step by step. Add AA2 under O to ein. Instructions getting confused with data. Add structure. Each common failure has a matching tool, so iterating is not random tinkering and 8212. It is diagnosing what is missing and applying the right technique. This is the real practice of prompt engineering, not writing one perfect prompt, but skillfully refining a good one, guided by the model N39's actual output until it reliably does what you need. In the lab, you will do exactly this N82 fall. Write a prompt, watch it fall short, and improve it step by step. So the takeaway: prompt engineering is iterative, and 82112, write, test on real and tricky inputs, and refine, changing one thing at a time so you know what helped, and 82112, and because each common failure maps to a specific fix, specificity, an example, step by step, or structure. Iterating is deliberate diagnosis, not random tinkering, until the prompt reliably works. Let us gather everything into a practical checklist you can run through for any prompt you write. Start with specificity, always. State clearly who the answer is for, how long it should be, what tone and format you want, and what it should focus on. This alone resolves most disappointments. Whenever you are about to send a prompt, glance back and ask an 80-200, have I actually said what I want, or am I making the model guess? ND200-200, 9 times out of 10, tightening the specificity is the single biggest improvement available to you. Make clarity your reflex. Then, add the other twos as the task calls for them. If the output has a particular form or style, include an example or two and let the model match the pattern. If the problem is genuinely hard and reasoning heavy, tell it to think step by step. And if the prompt is complex, with instructions and data mixed together, structure it and A212. Separate the parts with clear markers and label the sections. Specificity is your base. Examples, reasoning, and structure are the layers you add when the task needs them. Keep this order in mind, and you will always know what to reach for. Finally, treat every prompt as something you test and refine, rather than get perfect first try. Run it on realistic and tricky inputs. Watch where it falls short, and apply the matching fix, one change at a time. Over a few quick iterations, guided by the model N369's real responses, a mediocre prompt becomes a reliable one. Be specific by default, add examples and reasoning and structure as needed, and iterate on real inputs and 80-on-20. Those habits are the whole craft. Do them consistently, and you will reliably pull the best out of any model on any task. That skill will serve you in everything you build on Claude. So the takeaway: run every prompt through a checklist and 81-to-half. Be specific by default about audience, length, tone, and format. Add examples for a particular form, step by step for hard reasoning, and structure for complex asks. And test, then refine on real, tricky inputs one change at a time and A212. And those habits reliably pull the best out of any model. Let us gather the whole class in one breath. Prompts matter enormously and 8112. The same model gives a poor or a brilliant answer depending on how you ask. Be clear and specific. State the audience, length, tone, and format, and never make the model guess. Give examples and 8112. Show 1 or 2 good answers, and the model matches the pattern. Let it think, and 82-I12. Asking it to reason step by step yields far better answers on hard problems. Structure the prompt, separate instructions from data, and use clear sections. And iterate an 82-12 test on real inputs and refine one change at a time, applying the matching fix. Next class, NA212, tool use, letting Claude call your functions to act in the world, one idea at a time. That is prompt engineering